In this slide, we will be discussing how contiguous memory allocation works, its advantages and disadvantages, and where it's commonly used. So, what is contiguous allocation? It's a memory allocation technique where data is stored in a single block of memory that is divided into uniform sized cells to store n number of data elements. This block of memory is also known as an array. Each cell in the array is accessed using its index, and we need to know the address to the first cell and the total number of cells to use the block. Now let's discuss the advantages of contiguous allocation. First of all, it's simple and easy to implement. Additionally, accessing elements in an array is very fast since we can calculate the memory address of each element using its index. But like any other techniques, contiguous allocation has its disadvantages too. One major disadvantage is that we need to allocate memory for all the elements of the array if we don't need them all, even if we don't need them all. This can be a waste of memory in some cases. Additionally, if we need to add or more elements from the array, we need to allocate a new block of memory and copy the existing data over the new block. Now let's talk about where contiguous allocation is commonly used. It's used in data structures such as hash tables, adjacency matrices, stacks, and queues. Hash tables use contiguous allocation to store key value pairs, while adjacency matrices use it to represent graphs. Stacks and queues use contiguous allocation to store their elements, with the index indicating the position of the top of the stack or the front of the queue. In this slide, we will be discussing the advantages and disadvantages of contiguous allocation in data structure. Contiguous allocation refers to a memory allocation technique where a single block of memory is divided into uniform sized cells to store a fixed number of data elements, usually accessed through their index. This technique is commonly used in many data structures such as an array, hash table, adjacency matrices, stacks, and queues. But what are the advantages and disadvantages of using contiguous allocation? Let's start with the advantages. First, contiguous allocation is easy to use as accessing elements is as simple as using their index. This makes it easy to implement algorithms that rely on fast element access, such as sorting and searching. Second, contiguous allocation provides good cache locality, meaning that the data is stored in a way that is friendly to the cache memory of the CPU. This can result in faster access times and better overall performance. However, there are also some disadvantages to consider. One of the main issues with contiguous allocation is memory wastage. If the actual number of data elements is less than the capacity of the block, some memory cells will be felt unused, leading to inefficient memory usage. Another disadvantage is that contiguous allocation is not dynamic, meaning that if more memory is required at runtime, a new block of memory needs to be allocated, which can be time consuming and require copying all the data to the new memory allocation. This can also lead to the memory fragmentation, as smaller blocks of memory may be allocated instead of a larger continuous block.